Good morning, students. Welcome to the lecture series of Formal Language and Automata Theory. And today we are doing some example on how to get a regular expression from the finite automata using a Arden's theorem. Now we will continue with the same problem. The example number 1. Here we will put the value of equation 6 in the equation 1, and the equation 1 which can be written as q1 equal to epsilon plus q1a plus q1b into b plus ab whole to the power clean closure aa. Here we have put the value of q3. Now take out the common term. Here we have q1, here we have q1. So take out the q1 as a common, then this equation can be written as a plus b into b plus ab to the power clean closure into aa. Now again we can see that this equation is in the term of a Arden's theorem. If we consider q1 as r, this as epsilon as q, then again we will get r, and this whole term as considered as a p. So again we are getting the Arden's theorem equation. So now this can be written as r equal to q into p to the power clean closure. So we can write down q1 equal to epsilon into a plus b into b plus ab whole to the power clean closure aa. Also we know that an epsilon multiplied with something, we will have something. Let me clear the screen. So here in the equation number q1, we have written the equation in the form of a r equal to q into p to the power clean closure, and the equation can be written as epsilon into a plus b into b plus ab whole to the power clean closure aa into the power clean closure. And anything multiplied with the epsilon will have a something. So now the equation q1, so we will get the q1, the value of q1 as a plus b into b plus ab whole to the power clean closure aa to the power clean closure. So this is the regular expression which is represented by the given finite automata. In this way, we can find out the regular expression which is represented by the given finite automata using the Arden's theorem. Now we will solve one more example. Now let's see the example number 2. Here we have a 3 number of state, that is q1, q2 and q3, where q3 is my final state and q1 is my initial state, and we have a 2 input symbol a and b. So first step is to write all the state in the form of a equation. So while writing the equation, we will see how many arrows are coming to each state and on what input symbol, on giving what input symbol from which state they are coming. So we can write the equation in the form of like q1 equal to q1a plus q2b plus epsilon, because Q1 is my initial state. तो जब भी initial state होता है उसमें हम extra symbol लगाते हैं, that is your epsilon. And you can see that there are two arrows coming to the Q1, Q1A and Q2B. Similarly, we will write for Q2 and the Q3. Now, put the value of equation Q3 into the equation 2. We have to put the value of equation 3 into the equation 2 and find out the common term, that is Q2B and Q2AA, as we have done the same thing in the previous question. Now we got the equation in the form of a Arden's theorem, which is R equal to Q plus RP. Here we have a Q, this as R and this is P. Then it can be written as R equal to Q into P to the power clean closure. So here we have written Q1A into B plus AA to the power clean closure. Now we have to substitute or we have to put the value of Q2 into the equation number Q1. So now the equation Q1 can be written as Q1 equal to Q1A plus, here we have put the value of Q2. So Q1A into B plus AA whole to the power clean closure B plus epsilon. Now put the take out the Q1 term which is common in both the term. So हम लोग यहाँ पे Q1 कॉमन निकाल लेंगे. तो now it can be written as A plus A into B plus AA whole to the power clean closure B plus epsilon. Now write this equation as Q1 equal to epsilon plus Q1 A plus A into B plus A plus A into B plus AA whole to the power clean closure plus into B. And again we can see that this equation in the form of a R equal to Q plus RP, where R Q1 is the R, epsilon is the Q and P is the A plus A into B plus AA whole to the power clean closure into B. So we can write down this equation as R equal to QP whole to the power clean closure. So when we will write the equation in the form of this, so we will get the final, the value of Q1 as like, you will get the value of Q1 is like epsilon into A plus A into B plus AA whole to the power clean closure B into whole to the power clean closure. And we know that anything multiplied with the epsilon will be the same. Now we will put the value of Q1 into the Q2. So this equation we will get and put the value in the Q3 also, since Q3 is my final state. So the set of string recognized by the transaction graph is given by this. In the previous question, Q1 was my initial state as well as the final state. तो हमने Q1 का जो फाइनली स्ट्रिंग प्रोड्यूस किया उसको हमने लिया कि दैट इज द रेगुलर एक्सप्रेशन एक्सेप्टेड बाय द गिवन फाइनाइट ऑटोमेटा. नाउ हियर Q3 इज माय फाइनल स्टेट. तो आपको क्या लिखना है, जो फाइनल स्टेट स्ट्रिंग रिकॉग्नाइज करता है वही आपका रेगुलर एक्सप्रेशन होगा. सो वी हैव टू कीप टू थिंग्स इन माइंड.